So in the case of dialogue with scheme, you have that if you enter constant, it is going to return constant, same as what we did last time. So constants can be real numbers, can be exponential numbers, can be integers, and whatever constant you enter, it is going to return back. So if you enter operators like plus or minus, they are going to return the neutral element for this operation. So multiplication has neutral element 1. However, there is the difference between Texas Instrument Scheme, which is shown here, and Racket. Racket is not giving 1 as neutral element for operation of division, and therefore it is not going to return this. It is going to ask for 1 argument. So if I go, let's go to Racket. Racket is here. And then if you say 1, 2, 3, I am returning 1, 2, 3, 3, 4, 5, 6, 6, 6. All this is returned directly. But if I enter multiplication without argument, gives me 1, which is okay. But division is not giving me 1, but is giving me arity mismatch. So if I want to have division, I have to have a value. So if I want to divide 1 divided by 3, then I have to have division, or I have to have division 3 divided by 2, get 1.5. So division works differently from Texas Instrument Scheme. And there are those little differences here and there, and you have to be warned that they exist, and that's not important. It is not going to disturb you at all, but I just want you to know that this is done that way. So let me go back to our lecture here. So in the case with a single operand, if you have addition or subtraction or multiplication or division, all of them work with single argument. And this is also different between Texas Instrument and Racket. Racket is giving you 1 divided by 3 here, not 0.333. So Racket is doing that more carefully than Texas Instrument Scheme, but you have also MIT scheme that has differences from this. So this is normal. So as we said, if you have division of 3, this is not going to be 0.333. You have to have 3, which is real value. So if 3 is real value, then you get real value as a result. If you have integer, it is giving you rational numbers. That's what Racket is doing. That's how Racket is designed. So that's not a big difference, but it is good to know that such differences do exist, and we have to be warned about them. If you have 2 operands, then you perform operations of addition or subtraction, multiplication, division, which again here works with real values. You can have multiple operands like plus 1, 2, 3, 4, and this is first applied plus 1, 2, and then plus 1, 2, plus 3, and so on and so forth. So you have that this is equivalent to this binary operation plus first 2 arguments and then plus third argument and plus fourth argument, etc. So this is what is assumed. So if you have minus here, then you get minus, minus, minus. So you have that the first value comes with its original sign, and the rest of them are with minus. So that's the reason why you have here minus 8. So minus 2, minus 3, minus 4 is minus 9, plus 1 is minus 8. Multiplication of these numbers 1, 2, 3, 4 gives you 4 factorial or 24. Division gives you division 1 divided by factorial, which is 1 divided by 24, which is this here. You can have huge numbers in exponential notation. For example, 1 times 10 to 77 divided by 1 times 10 to 75 is 10 to 2 or 100, and this is the result that we get here. You can have also division of real number by integer. That's perfectly okay. So 7.777 divided by 7 gives you 111.111. Then if you enter huge integer, like this one here that has exactly 30 digits, it is going to be returned in the same way. So this is the same value that is returned. Obviously, when we do that, we are not processing anything, but this shows that internally these big integers are stored as lists of digits rather than binary numbers, and therefore we have that there is no limit of the size of integer. Exit is command that is going to bring you back to the operating system. So in the case of Texas Instrument Scheme is giving numbered lines of code. So 22, 23, 24, 25, 26, etc. And there is a possibility to have this transcript simply sent to script file. So I was doing this with script file, and then after that we'll edit this script file. So for example, if I have somewhere a command that I had a typo or make a mistake, I will simply erase that, and then you will have a 22 and then 24, and 1 is missing. What is missing is what had typo inside, so don't worry about that. In the case of Racket is not putting these numbers, but giving you just usual, giving you prompt, which is this greater than. So if I ask whether 3 is greater than 5, for example, the answer will be false. It is not. So this here is prompt, and this here is greater than operator, and this returns a value. It is a function. So in the case of atoms are indivisible data objects. So these are numbers or strings or symbols. So here are atoms like 123 that returns 123. Semicolon is used for comments. So whenever you want to make a comment, you start with semicolon. So from here to the end of line is going to be comment. You have also real numbers in exponential form. If you want, you can use them. All character strings must be written with double quotes. So double quote character string, double quote, and you get character string. Character string can have digits or any characters inside. So this is obviously not number, but it is a character string. There is also empty string. When you put double quote next to each other, this is important because it returns nothing. So when you need to return nothing, you can display empty string. So for example, if you want to have something that has no value, for example, if you say display, display is write command. It is displaying this value. So it displays 33. But if I say display 33 as a string, like here, you get again 33 because this is a string and has the same interpretation as 33. However, if I go here and return the empty string, that means I return nothing. And this is a good thing to have, because sometimes you have functions that have to return something, and then if you want to do only side effects, you don't want to return anything, then you display an empty string, and this is equivalent to returning nothing. So that is sometimes necessary, and then when we use that, we use this empty string. True and false can be written in a variety of ways. True can be written as true, but internally it is always pound T for true. Uppercase, lowercase are acceptable. True as the word is acceptable, and false is also acceptable as word. However, internally, this false is practically a pointer to nowhere, pointer to zero location. And Texas Instruments and this reader have for false an empty list. So this is a strange thing, because this is another difference between Racket. In the case of Racket, you have that false is always pound F. There is no way you can do that. So if we go, let me show you for a second. Okay, we are switching between Racket and that. So if I have false as the variable, it returns F. I can have pound F capital, it is again false, or pound F lowercase, it is false. Pound F is also used, or any kind of these falses are the same and truths are the same. So it is not possible to get empty string, because empty string is considered here missing procedure. So probably originally, which is an illegal empty application. So that's how it is defined in Racket. If you create empty string which is quoted, empty list which is quoted, that's perfectly okay. So this is like a list where you have some content, 1, 2, 3, for example, but you have no content. So you go here, remove everything, and get empty string. However, this here without quote is no procedure. Therefore, it is an empty function that is doing nothing, which is illegal in Racket. So don't do that. In the case of Texas Instruments scheme, this is the way how they denote false, and this is a minor difference, and you have to be aware of that. Even nil is returning this value. You cannot use something that is undefined. So if you say variable, it is saying not defined in current environment. If you want to exit from the specific session, you enter the exit command. Exit command brings you to the level of session, and this is interactive session between user and scheme. So let us speak a little bit about symbols. So symbol is the name of variable, like this X here. So if I enter X, which is undefined variable, obviously I'm going to create an error. So variable is not defined in current environment. So if I go to these messages are slightly different between Texas Instruments and Racket. But if I say here, for example, Q, Q is undefined variable. It said Q undefined, cannot reference an identifier before its definition in module top level. So I have to say define Q, and I have to give value to this Q. So for example, this is the value of that Q. And if I do this and say, show me Q, it is going to be this numerical value. You can redefine Q. You can come and say, now Q is going to be, is going to be not this, but it is going to be 13. Okay, so we redefine that, and if you want to see Q, now Q is 13. Q is the name of variable that is stored in symbol table, and this is the value of that variable. So we are going to return to this in a minute. Let me tell you what I have about the correct definition of variables. So if you have an expression that includes undefined variable like this x, this is not going to work because variable is not defined in current environment. True, false, and nil, all of them are predefined, so they are not going to make any problem. Same is with false. And true, also, you can define symbols. Symbols are written as quoted values. So you have quote and name. Now, what is the need, why we need symbols? Well, because we can have symbolic calculations. So if you want to have, for example, a program that is computing derivatives of functions. So you can say if I have x to third degree, so x to third degree, derivative of that is 3 times x to second degree. Okay, so you have to have this x, which is a symbol, and therefore symbols are written in this way that is shown here. You have quote, and after quote you have the name. The name can have any number of digits, of characters, so A, B, C, D, E is a legitimate symbol. You can also quote expressions. So this expression here, plus 1, 2, is quoted, and that means you are disabling evaluation of this. Quote is disabling evaluation. So if I have, for example, this quoted list, so you can have define like this, define something called F, and this F is, for example, here plus, let's put plus 1 and 2. So if you ask what is F, F is this quoted list. You don't execute that. If you want to execute that, you have to remove this quote, and this is done with eval F, and then when you eval F, then you get that this is operation that is now activated. So this eval and this quote cancel each other. So eval is removing this quote. I'll show you a little later a few examples of that. But at this moment, you have that this is not an active expression. This is simply a quoted expression, which is having the status of constant. And then if you remove this quote, then this becomes a function that operates and returns the value. So it's an evaluate this F, that means I'm removing this quote, I get this expression. This is a function, addition, these are arguments 1 and 2, and the result is 3. It should be that way. Okay. Now, let's go to see recognizers. Symbol with question mark is recognizer. There are plenty of recognizers in this table that we studied last time. So they recognize what is the type of object. All of them return true or false. So you ask whether X is a symbol. Yes, it is true. Whether number 7 is a symbol, it is not. It is false because number 7 is supposed to be numerical value, and if it is a symbol, then it must start with letter, and so this is not symbol. nor 7 itself. Expression is not a symbol. So the symbol is only what is symbol, that were quoted regular name that starts with letter. If A, B, C, D, E is symbol, yes, of course, this is symbol same as A, B, same as A. So these are all symbols. Of course, the most important thing in each language is the symbol table. Symbol table is the table that includes the name of object, and then after that several columns that are giving more specific explanation of that name. So if you have that we define variable x that has the value 1, 2, 3, what does that mean? That this define is going to make a new entry in the symbol table. And this new entry is going to be the name x. And then there is going to be the data type, integer, which is internally coded. We don't care about that. And there are various other internals. For example, if it is list, it is going to have pointers to the first and last element, and who knows what else, depending on how this is internally organized. However, there is a value that is stored somewhere in memory. So the symbol table has the name of an object, and then various internal data, and then pointer that points to the place in memory where that object is located. Okay, so that is what means define x1 to 3. So from programming standpoint, this is just variable x, which has the value 1, 2, 3. So if I say show me x, it is going to return 1, 2, 3, as it should be. I can define y, which is 321, and then I have these two objects, 1, 2, 3, and 321. If I try to use x before it is defined, it is undefined variable, and this is, of course, illegal to use. So don't use undefined variables. Variables have to be defined before they are used. Then we have, if I have these two variables, 1, 2, 3, and 3, 2, 1, I can now make operations with these variables. So I have addition, which is function. These are arguments, x and y, and the result is 4, 4, 4. If I quote that, then it is quoted expression. It is not activated. It is not operating and creating results. It is waiting to be used for something. I can also define function in the same way. So define is putting in symbol table function. So what is the name of that object? Double. Double is the name of that object. What is the argument? Argument is x. And here I have that this is 2 times x. So this function double is practically multiplying x by 2. So if I say double of 1, 2, 3 is 2, 4, 6. So why is this defined in this way? Well, it is defined in this way because this function can be defined in 2 different ways. It can be defined in this way, or it can be defined as a lambda expression. So if I go to, for example, define this function. So say define define, we say double of n, and this is multiplication of 2 and n. Okay, that is okay. So if I say give me now double of 22, I'm going to get 44. However, I can also define double in a different way. I can say define, let us say D. Okay, that is a function. So I'm going to make lambda of n, and then will be multiplication of 2 times n, like this. Of course, I have to put here lowercase n, and I need to put one more parenthesis. When you do that in Racket, it is doing this in simpler way. It shows highlighting of parentheses, so to see where is left and right. The same thing will happen if you work this in Notepad++. Then if you say I'm working with Scheme or Lisp, then this last parenthesis and first parenthesis will be red. So you see what is the opening and closing parenthesis. So what is important here? I'm defining this D the same way as if I define any other constant. So if I say D apply to 33, I'm going to get 66. So this is doubling. But however, what I can do is define x to be 123. So I want you to see that there is no difference between this defined here and this defined x. So what I'm defining? I'm defining an object that has the name x and the value, which is a constant, 123. Now what happens here? I'm defining an object that has the name d and the value which is constant. And constant is this lambda expression here. So this function, lambda of n, which is 2 times 10, is constant like any other constant, like number 123, completely the same thing. Where is this stored? Somewhere in memory. So you have in symbol table column, which is called D, the name D. And this D is then identified as a function, and there is pointer to that object in memory, which is a function, and then you go there and grab that function and work with it any way you want. So you can define this double function either by giving name, and this is abbreviated form, name and variable, in which case this is the function and this is its argument. Or you can say I'm defining this object D, which is lambda expression, and this lambda expression is a constant. So there is no way of doing this differently than this. This is just abbreviated notation. So when you have this abbreviated notation, you will still have lambda expression that is created here, stored in memory, and then this double is stored in symbol table. Any question about this? No questions. Okay. So let's go back here to the reader. So you can have various operations. For example, if you have this double, you can say subtract 1 minus 2, get minus 1, then apply double to that, and it is going to be minus 1 times 2, which minus 2. So you see function inside the function. I have here minus as a function. Arguments are 1 and 2. 1 minus 2 is minus 1. This result is then given as argument for function double. Double of minus 1 is minus 2. Now I define this square either in this way, square as n times n, or this square 2 defined as lambda of n, which is n times n. Can you tell me what is wrong in this definition? Huh?
You didn't close the paren. Shouldn't lambda n be self-contained?
No, that is okay. The problem is that and you are going to always make these kind of errors because we write expressions in procedural languages. I didn't put space between asterisk and n. And language processor cannot understand that this is multiplication. So if I go to compute square root of square of 2, square 2 of 10, it is telling me that this variable asterisk n is undefined in lexical environment. So you must always put spaces as separators between objects. Space is the part of this language. Of course, here between lambda and n, you can put spaces. It is not going to make any difference. But here, it is indispensable to have space. So I made a mistake to put these things in fast typing, didn't put this. And this is going to happen to you many times before you learn that you have to deal with space, because our basic instinct from all procedural languages and object-oriented languages is that you put spaces for readability and for beautifying things and not for functionality. Any compiler is kicking out all these spaces immediately and then analyzing what is inside, because this is just for humans. So here is not that way. Space is the part of the language. So here is the definition, square root square 2, which is defined as lambda of n, and then you have to put space between this asterisk and n, multiplication of n times n. And in that case, of course, this square 2 is working correctly. You can also define functions that use your previously defined functions. This is completely legitimate. So this square 3 of n is using square of n, which we defined a minute ago. So that's okay. Square 3 of 15 is 225. Okay. Now, there is another thing that exists in languages like Fortran or Pascal. These languages can have function as local function of another function. And this is a very useful thing, that you can have function inside function. And when you do that, you make the private function of some function. So that is a very useful thing. Like, for example, this here is defining this square 4 of n, which is defined as, let me see if I say Control C, could I copy this here or not? Just a second. Ha! Very good. Didn't know that I can copy from one to the other. So this is, so look what I'm doing here. I have this function square 4 of, let me say square 4 of 10. So this should give me 400. This is actually using this function SQR of 10. So what I have, that this function is defined inside the function. And there are two possibilities. Either this is the local object of this scope, or it is available globally. So here is available globally in Racket. So what you have, that some languages, like for example, Pascal and Fortran, have this as a local function of this outer scope. Here it is defined globally. So what happens here, I define square 4 of n. And what I want to do, I want to use function SQR of n. But I don't have this function. So before using it here, I have to define it. So here is the definition. So what I do, I define this square 4 of n. And before that, and inside that definition, I have another definition. So you can have define, inside define, inside define. So you define this function square of n is n times n. And then after it is defined, I can use it here, SQR of n. And then you can have both of them that are working in Racket in this way. Okay. Now, in Racket and in Ruby and in many languages that use dynamic typing, we have that all objects are dynamic, are created at runtime. So there is no static typing. You cannot say the integer I, and then during the whole program, you have access to integer I. This is not possible. You are creating dynamic objects and using these dynamic objects. So no static data types. And you will see in Ruby that this needs rather careful programming. Programming with dynamic objects is different from programming with static objects, particularly in Ruby, where the data type is defined at the moment of assignment. So in Ruby, if you say x equals 3.14, at that moment, this x becomes real value. If I say x equals 3, then this becomes an integer. Now, if you write a function that is doing, for example, matrix inversion, that has to work with real numbers, and you put inside integers, it is going to work with integers and will create wrong results. So you have to be very careful when you have dynamic typing that the type of object is defined at the moment of assignment. So when I say define x 1, 2, 3, 4, 5, 6, 7, this x has no data type at all. It gets the data type at the moment of assignment, and now it is an integer. So if I say show me x, it is 1, 2, 3, 4, 5, 6, 7, fine, integer. But immediately after that, I say define x as 1, 2, 3.456. So now it is a real. And what happens is that this entry in symbol table is erased. And now you have the new entry that is having the name x and has this new value. So the pointer to this 1, 2, 3, 4, 5, 6, 7 is removed. 1, 2, 3, 4, 5, 6, 7 is no longer accessible. Garbage collector has to come and reclaim that memory for recycling and using during the execution of that program and other programs. So dynamic memory has to be compacted and you have to have it available for other operations. And here we have the new value that is stored in memory and pointer to that new value. So if I say now show me x, it is no longer this value integer, but now is this real value. Immediately after that, you can define x to be string. And then if you say show me x, it is string. Or you can define x to be a list. And this list has 1, 2, 3, 4 values. If you say show me now x, x is now 1, 2, 3, 4. So one thing that is important to see here is that these objects are dynamically created, dynamically assigned values, and then after you use them, then you have that you can redefine them any way you want. For example, here is define x as plus ab. So this is an expression. A and b are undefined variables, but since we don't execute that, nobody is touching that. If you say show me x, it is plus ab. So is definition assigns a new value to variable, and then it destroys previous object. So it has constructors and destructors. You have the possibility to create and to delete object. Now, Texas Instruments scheme, which is used for this reader, has one beautiful little feature that you can populate the symbol table in 2 steps. You can say define x. That means you enter the symbol table and put the name x inside. Now, you should give also the value. That means value in memory and pointer between that. But you can do that later if you want. So if you say define x, Texas Instruments will accept that. When you say show me what is x, it is going to tell you unassigned. What is perfectly okay. It is not assigned, but it is in symbol table. Of course, this is different from Racket. Racket is not going to accept that. So you can use set to assign the value. For example, set this x to be 3, and you get that now x is 3. And set y to be 4. This is not acceptable because y is undefined. So let us play a little bit with that to show you that this doesn't work in Racket. So in Racket, I can define x to be 1, 2, 3, for example. And here we have x which 3. So that's perfectly okay. Now, if I go and say I'm going to redefine this value, so say set, set has exclamation point, which is for those things that are forcefully in situ changing the value of an object. So if I say set x to be 3 to 1, this is now modifying the value of x, and x is same in symbol table, but the value in memory is changed from 1 to 3 to 3 to 1. Now, if I want to say set, set y to be 3 to 1. How about this? Well, I already had some y, so let me put some variable that I don't have here. For example, v. Okay, this is an error because unassigned assignment is not allowed. Cannot set variable before its definition. You have first to define variable and then to set its value. So this is so in Texas Instrument, and it is also in Racket. However, if you come in Racket and say define v, so I want to define this name and later to use set to set its value. This is acceptable in Texas Instruments scheme, and it is not acceptable in Racket. Here we go. So it says bad syntax, missing expression after identifier. So you have identifier. Identifier is v, and after that you have to have expression. So you have to say that this is equal to something. So for example, it is 5 factorial, okay? And if you ask what is v, you are going to get 120. So we have that we define an object, give it the value. And this is legitimate. This here is illegal. So pay attention that there is a little bit of difference between a reader and this Racket that we use currently in this sense. So you have to use a set only for variables that are already defined. You cannot have undefined variable and set its value. Of course, if you define y to be 4, that's perfectly okay. You can also define something to be operator. So this is not legal in Racket, but you can say operation with set assign the value of an operator. So if I have here operator applied to 3 and 4, then I have 7. Okay, so the good news is that you can apply any function to that operator, whatever you want. So if I go here and say define define an operator to be, let us say, plus. So this is legitimate assignment. I defined op to be a procedure. I can ask, what is this op? Op is a procedure plus. Okay, so we now say op, perform operation between 3 and 4, 2 and 4, for example. Okay, so the result is 6. However, I can now come and say, let me redefine that. Set, let us say, this up to be not operation of addition, but to be multiplication. So I can assign the value of multiplication to up. So you practically give the new value of function to previous value of function, which is completely legitimate. This is functional programming. Yes, what is up? It is multiplication. So if I go back to up to 4, I get 2 times 4, which is 8. Now it is a different function. I can also go and say set this up to be my own function. So I can say lambda of n, which is n times n times 10. You have to put all these spaces, okay, like this. And now say up, you cannot have 2 arguments, but you have to have 1. And you put 1 argument, op 4 is 16, simply because op now is a procedure op. And so what is that? That is this lambda expression. So I want you to note that this plus here and this times and this lambda expression have exactly the same kind of treatment. These are constants. And each function is a constant like any other value. This brings us to that story of first-class objects. First-class objects must have an anonymous intrinsic value. And that's the first thing, literal value. Therefore, all objects must have possibility to be constants. In C and C++, you cannot have function that is a constant, and I cannot assign this constant to another variable because it doesn't support functional programming. And functional programming, you have that function is constant like any other constant. You can assign that to any value and manipulate these constants in variety of ways, in various tricky ways. So what is going to happen a little later that I'm going to have lambda inside lambda. And this is going to be a beauty because you're going to have now function inside the function, and you can combine them in fantastic ways, which is unheard in object-oriented and procedural programming. It doesn't have these possibilities at all. So at this moment, it is important to understand that this lambda expression here has the status of constant. And this is that every object must have a literal value. And function is an object, therefore it has to have literal value, and it is treated as a constant. Okay? Any question about that? Okay. Now, reading from, of course, you can have read operation like in any other language. Now, read operation is performed with function read. So if you have read in parentheses like this, it is read that has operator but no operand. If you have read and after that you say what is the port you are reading from, then you are reading from a specific port which is connected to file. So I can open file and assign to specific port. And then I read from that port, that means I am reading from file. So you can read from file. If you don't have file name, then default is reading from keyboard. So when you say define F and read it from the keyboard, then you have that system is going to wait here until I enter something, and I enter 123. After that, you say, show me X. X is 123. So you read that from the keyboard. Then you can set X to be changed from keyboard, and then I enter 321, and then result will be X is 321. If I define X to be read from keyboard and enter more than one object, like 1 followed by 2, 3, only the first is going to be extracted because it is one object that I am reading here, and therefore I have to extract only one of them. I can define pair. Pair is a binary tree. This dot is the dot that was used in Prolog. This dot in Prolog was literally stolen from Scheme. However, they decided now in SWI Prolog, as you know, to use that for dicts. And now it is no longer working this way. But in Scheme and in Lisp, of course, this is construct, the basic thing that makes binary trees. So this is a binary tree that has two objects, 12 and 34, two numeric objects. This is not a list. It is a tree. List is terminated with empty list. So if I say show me P, it is 1234. 12 is car, head, 34 is scooter. It is the tail. There is also possibility to have a sequence of statements, like define A and read it from keyboard, define B and read it from keyboard. So if you enter 1 and 2, then 1 is going to A and 2 is going to B. And then if you say show me A, show me B, you get 1 and 2. One thing that you can do, you can set A to be read from keyboard, set B to be read from keyboard, and then display A, put space, display B. Now, one thing that is different between Texas Instruments Scheme and Racket is that you have the possibility to read these two values and then to display them. But then this begin is a control structure. So this gives you a sequence of expressions and returns the value of the last expression. And if I don't have this non-printing object, it is going to return this B. So you have this thing here, X. Define X read, it gives you this and prints this X, because it has to return something. So all of them have to return something, and this one here returns the last value, which is this B. That's why this B comes here. There is a possibility in Texas Instruments Scheme to say return nothing, which is done in two ways. Either you say display an empty string, or you say the non-printing object. And then you have the non-printing object. That means this is nothing. It is pointer to nowhere, or it is same what you get when you say display an empty string. There is nothing inside. So returning nothing, because all this what we do here are side effects. Another thing that is important is the let scope. Let me actually show you a little bit of read command. Let me show you a little bit of read command. Let me go back to Scheme, and let me define function f as read. So I want to read this function from the keyboard, and then I'm going to read that as this lambda expression. Okay, so I go here, enter this lambda expression plus return. That's it. So read f from keyboard. Keyboard is lambda of n is n times n. If I ask show me f, f is displayed as this lambda expression, but it is quoted. So this is quoted object, which means it is disabled to perform operation. So if I say I have this f and apply this f to 3, I want to compute 3 times 3, 9. This is not going to work, because it is going to say not a procedure, because this is here an object that is not activated. So I have to deal with this quote, to remove quote to make this an active function. So to remove that, I have to use evaluate this f. And when I evaluate this f, actually, I'm not going to do this. I'm going just to evaluate f. And what returns now? It says procedure. It doesn't know which procedure, but it knows that it is procedure because it eliminated here. It knows that it is lambda and it is some kind of procedure. What kind of procedure? Anonymous procedure. Okay. So now I can use this eval and apply this to my 32 to get 1024. So now I have that I read from the keyboard this function as a constant. Then I activated that by removing this quote and then applied this function to 32, and this returns the value. So this is operator, this is operand, this is result. Is this clear what I'm doing here? Okay. Now let's go back to the reader. So there is a possibility to create a program with let scope. So what is let? When you define let like this, let is giving you the possibility to create local objects like this A and B and C and any number of them. You define local variables and you have a program that is working with these local variables and returning something as the result. This A, which is defined here, is local scope. That means when you go out of this let, A is going to be undefined. It is defined only from here to here. So what I say, let A read, and then after they display A equals and display A. So this is going to wait for me to enter the value. I enter the symbol alpha, and then you write A equals this symbol alpha capitalized for Texas Instruments because it is case insensitive. In the case of oops, this is working. Control C, I guess. So let's go to play a little bit with this. So if I put this let scope, then it is going to wait for me to enter value. So I enter 1, 2, 3, and it is displaying A is 123. So perfectly okay. If I say now, show me A, it says A is pair 1, 2, because I used previously this pair. So you see that this A here is a local variable. So it created this A, it instantiated A from this 123, it displayed A equals, then took this A that is local A, and then went out. When I came out, I say, show me A. It says it is pair 1.2. Okay, I can say, show me a car of that A. That means head of the list, it is 1. Show me Kuder of that list. Oops. Show me Kuder of that list A, and you are going to get 2. Okay. Pay attention that Kuder of list that has 1, 2 must be a list. Do you see it here? It is a list. It is not 2 pair. So this here is a 3. It is a pair 1, 2, and this dot is gluing together 1 and 2. And here you have the list, which has 2 and empty list at the end. Okay. So it has car and Kuder of that. So you can say car of the list that has inside 2 is of course 2. But if you go and say, show me Kuder of that, oops, Kuder of that, it is an empty list. So you see that there is 2 and there is empty list as a terminator in that 3. So that's the way how it should be. Okay, so let's go back to the reader. Therefore, we can define these values, like, for example, define this Z that is read here, display this Z, and then after that, you ask, what is car of Z? It says, I never heard for that. Variable not defined. Z is not defined. Why? Because Z is local variable that was created for this let scope. Scope is limited from here to here. Now, one thing that you should note, do you see this double parenthesis here? Is this looking strange? And double parenthesis here, if I'm closing that, this double parenthesis, these two. So normally people will say, hey, if you have double parenthesis left, double parenthesis right, this makes nothing, reduce that to single parenthesis. Don't do that in scheme. For what reason? Because it is a part of syntax. So this let scope has this parenthesis as, and this parenthesis as its part. And then inside these two, left and right. And inside, you can have any number of objects. And this Z that is defined from here to here is from here to here, is the object that is stored inside. So these double parentheses tell you that you can have many objects inside, and you put only one, which is legitimate, but you cannot change the syntax. So you have to have this parenthesis here at the beginning, and this one at the end, which is telling you that inside you put something. That's the meaning of this double parenthesis, and you should have understanding of that. Now, a few words about elementary functions. Absolute value, quotient, modulo, 7 modulo 2 is 3. Truncate is truncating this to integer value. Floor and ceiling, floor of 3.14 is 3. Floor of minus 3.14 is minus 4. Square root works normal way. Logarithm is natural logarithm, and exponential function 2 to 3 is same as power in C++. Power 2 to 3 is called here exponent. Greatest common divisor between 11 and 32 is 11. Least common measure is 33. Exponent, of course, power function can have real numbers. Here is 2 to 3, but little more than that. Pi is available as a constant. Pi divided by 4 is 45 degrees. So if you say, give me tangent of 45 degrees, tangent is 1. Okay. So if you say, what is arcus tangent of 1? Arcus tangent of 1 is pi divided by 4. So when I subtract pi divided by 4 and arcus tangent of 1, I must get 0. So that's perfectly okay. And arcus cosine is given here as inverse function of cosine. Minimum and maximum work for any number of arguments. So in the case of text instrument scheme, there is also function inspect. Inspect function gives you possibility to see the symbol table. This is not available in text and instrument scheme, but just to take a look. So if you enter Control A in inspect mode, it tells you have variables A, X, Y, and Z, these variables here. And what is A? A is defined, but not assigned. It is unassigned. X is something that has value 1, 2, 3. And then Y is the name for string, which is stored somewhere in memory. Z is the name for another 1, 2, 3. And then you have variety of functions that are available when you start your system. This is same logarithm, tangent, cosine, you name it, gazillion of them. You can create your own function, like cosine hyperbolic of x, which is exponential of x plus exponential of minus x divided by 2. So this here is shown to show how pretty print works in text and instrument scheme. Pretty print does not exist in Racket, and we are going to skip that. And now we will focus on three different forms of equality. And this is something that is very important because we said in the case of racket that we have the possibility to, not in the case of racket, in the case of prologue, that we have different kinds of equality. So in the case of racket and scheme, we have arithmetic equality. For example, we ask whether 2 or 5, for example, is equal to multiplication of 2 and 2.5. So what we have here, 2 times 2.5 is 5. This is equal to 5, and you have that the answer is true. So you can also ask whether this is greater than. So if I put here greater than, the answer is false. 5 is not greater than 5. However, if I ask, is it greater than or equal to 5, then the answers will be true. So this equality here is the same equality arithmetic that we have everywhere. Now, there is another equality in a scheme which cannot work like this. So this works for numbers. If I put here list 1, 2, 3 and try to see is this equal to this list, another list 1, 2, 3, this is not going to work. It is going to say contract violation. The contract is that it is expecting a number and giving a list. So you cannot have this kind of equality. So if you have objects of higher complexity, like lists and vectors, then you use the function equal. So equal with question mark is going to tell you that this is equal to this, okay? And regardless how complex are these objects, it is going to give you that. This can be also vector. So you put this and this is vector. These two things are different. But if I have two vectors, this vector and this vector here, it is going to be the same. So equal is used for objects that have practically for lists and vectors most frequently. Equal gives true always when objects are printed the same way. So if you display them in display the same way, then equal gives you true. Okay. However, you can have also pointer identity. So if you have equal like this, you say EQ, then this answer tells you that you have two different vectors in memory and that they are not in the same location. Okay, so I can go here and say define list X, which is equal, let me put it like this, 1, 2, 3. Okay, so I have this list 1, 2, 3. Nice. 1, 2, 3 stored somewhere in memory. So now I go and say define list Y. This is completely different list. It has value 1, 2, 3. Now I am asking, are they pointer identical? For example, say EQ. Are they pointer identical? So if I say 1 and 1, are they pointer identical? Yes, they are. Oops. Okay. Are they pointer identical? Yes, they are. No problem with that. But if I go and ask, are X and Y pointer identical? They have the same value, 1, 2, 3, 1, 2, 3. It says no. But X is same as Y. Okay? So why no? Because these are two different objects in two different memory locations. So I can say define Y to be same as X. What is define define this. What is y? What is x now? X is 1, 2, 3. Y is 1, 2, 3. How about EQ now? EQ is true. Now, EQ was to be false here, and it is true here. For what reason? Because I defined X to be same as Y. Therefore, they are 2 pointers to the same memory location. And there is one more object which is used for having non-printable objects. So if you have various non-equivalent, non-numeric values, you use EQV. So EQV with question mark is used for comparing, for example, false and false. If I have false and false, it is going to tell me true. Yes, they are equivalent. They are the same. Okay. So if we return here back to the reader, you're going to see that we have one table that we offer here after many boring examples. All this is in this table where you have for various x's and y's, what is returned by EQ, EQE, and equal. If you have, for example, an integer n and compared with an integer n, both EQ and others will return the same thing. They are going to return true, true, true. And this is the check function that is checking that. So I have that I define n as 1, a real number as 1.1, Boolean as Boolean, and character is this \a. So I also have symbol, string, pair, and list and vector. So, and function. So that's all what exists in scheme. Integer, real, Boolean, character, symbol, string, pair, list, vector, and function. And then I try to check whether they are equal with EQ or EQV or equal. And then you see different answers that you get. So to summarize this, we have that EQ is used for pointer identity. Both EQ and EQV can be implementation dependent. So these two operators, use them very carefully if you know what you are doing. So you have to know exactly what you are doing. Equal is equality between two lists or two vectors, the structures. EQV is equivalence, same as mathematical equivalence between two non-numeric values, and equality written as equal is for numerical values. Okay, so these are 4 different equalities in scheme. Any question? If no questions, then I'll see you next Monday, and we are going to continue from here. And then we are going to have extremely important topic, which are control structures and how to use control structures. And after that, we can write programs. So thank you. That's all for today.
Thank you.
Thank you. And bye-bye.